Okay, so which topic did we finish on Thursday? Geometric design, right? And again, what were the parts of geometric design? We get 3 parts. Yeah. Okay, and cross section. Okay, horizontal alignment, vertical alignment, cross section. So now you see, you take 2 minutes to answer 2 questions, right? And the exam is when? In April. Okay, just to show you. Okay, anyways, so this is topic number 3. It is from chapters 5 and 6 from the textbook. Okay, and in this topic now we will go into the basics of traffic flow, okay, or the traffic flow theory. So traffic is, when the traffic is moving, it is made up of drivers and vehicles, okay, and they interact with each other, they affect each other, okay. We discussed it in the last or the first chapter as well. Drivers, road users, and vehicles. These are the 2 important components of the traffic system. So these 2 main units of traffic. So whenever we say traffic, traffic is made up of vehicles which are driven by drivers for the time being. So these vehicles and drivers, they affect each other, and they are affected by the elements of the road and the environment and so on. Okay. So now the problem with traffic is that, or the problem with traffic data is they do not behave in the same manner. So if you observe traffic now on the same spot, and then you observe tomorrow on the same spot at the same time, you will not see the same behavior. Okay. And same thing, if you observe traffic simultaneously at 2 different places, you will see the same effect. They will not be behaving in the same manner. And they have found there are 2 main reasons for it. There can be other reasons as well, but the 2 main reasons are variations in individual vehicles and variations in driver behavior. So variation in vehicles can include the mix of vehicles you have. What is the percentage of heavy vehicles you have? What is the percentage of cars and bicycles and bikes you have? Okay. Then the operating characteristics of the vehicles themselves. There are certain locations or certain countries in which you may find, even 3-wheelers are there. Okay, you may find a higher percentage of bikes, and there are certain countries in which older vehicles are more prevalent. They are more common as compared to certain other countries. Okay. For example, if you go to Pakistan, you will find vehicles which are from 1980s. Okay, and they are a lot, not a small amount, and they are driven regularly. Right? They are not using it as something from museum. They drive on it regularly. Okay, so vehicle characteristics change, and obviously we have discussed a lot about driver behavior as well. Driver behavior changes because of what? Psychology of the driver and personality of the driver. Okay, and even before in the first chapter, I told you that there are a lot of combinations. Okay, a driver who is very experienced, very skilled, but he is tired for now, or he is ill, he is not feeling well, he may behave differently as compared to when he is totally fit. Same driver, same road, same vehicle. Okay, so because of these things, the traffic behavior also changes because drivers are controlling the vehicles and these vehicles are part of traffic flow. So because of these things, traffic flow are never considered same. Now we discussed about types of highways in chapter 1 as well. I gave you 4 types main. What were those? 4 main types of traffic, 4 main types of highways.
The freeways and the
Local. Huh? Yeah, that is another classification based upon location, right? Urban, rural. But main, we have 4 freeways, arterials, collectors, and local. This is another classification. Like we just mentioned, classification can be on the basis of function. This one, freeways, arterials, collectors, local roads, this is what we call as functional classification. Classification on the basis of function of the highway. Then there can be urban and rural, which is classification on the basis of location of the highway. Where is it? This is another classification based upon type of traffic flow. So based upon the type of traffic flow, we can have 2 types of highways, interrupted and uninterrupted. Okay, so highways in general, any traffic facility there, like any road and highway, they are calling it as a traffic flow facility. So traffic flow facility is nothing but roads and highways. Okay, so on the basis of traffic flow, there are 2 types of roads and highways, interrupted and uninterrupted. Now interruption means what? Yeah, stopping something, right? if you interrupt something, that means you have stopped its flow. So interrupted, yeah, okay. The first one is uninterrupted, but interruption means that you are stopping the flow, right? You are stopping the traffic flow, and we are talking about from the point of view of design. So it's not like something happened on the road and that everybody stopped for 1 minute. This is not the type of interruption we are talking about. We are talking about where traffic is interrupted because of the design of the road. Okay. So a facility which has this type of interruption in its design, we call it interrupted flow facility. And the facility which does not have any interruption in its design, we call it uninterrupted flow facility. Clear? Any stoppage or interruption to traffic which is part of the design, then that will be interrupted. If it is not part of the design, it is uninterrupted. Yeah.
The stoppage isn't something negative or like a sign.
Yeah. A stop sign is an interruption. Okay. So, like I was saying, these interruptions, like a stop sign, they are part of the design of the road. Okay. Another one can be, give me another example for interruption. A signal, traffic light. Okay. So we call them external interruption. Okay. Because this interruption is independent of traffic. Whether you have less vehicles on the road or more vehicles on the road, this interruption is there, right? Even if there is no vehicle on the road, this interruption is there. So we call it external interruption. So uninterrupted flow facility does not have any external interruption. Okay, what I was calling as that interruption by design, we call it external interruption. So the roads and highways or traffic facilities which do not have any interruptions, they call it uninterrupted, and another name given to them is, or another name given to this condition is full access control. Another name, when you have uninterrupted flow, another name given to this condition is full access control. Now, why do we stop traffic? Why do we want to stop traffic? Why do we want to interrupt? the traffic flow. Like when I say we, I mean the traffic engineer, the design engineer. You want to keep the traffic moving. At what condition, in what situation, you will try to stop it?
Conditions that may happen an accident.
Huh?
That may cause an accident.
Okay.
Intersections.
Intersections because?
Because you have four ways. You should
Yeah.
go.
So you are providing, when you stop one side, you are providing access to the other side. So if I don't provide these interruptions, that means access is totally controlled. Control means it's restricted, completely restricted. So traffic flow is continuous, but the access is controlled, restricted. Okay, so this is what they mean here. Full access control means now everybody is restricted from coming towards the highway. Okay, so when you have uninterrupted flow facilities, the access is controlled. Controlled meaning restricted. Okay, and this can only happen when you have no intersections. Otherwise, like he said, if you have intersections, then you have to provide access. Okay, then you have to provide interruption. If you don't provide interruption, then there will be accidents. Okay. So from the previous classification we had, freeways are considered as uninterrupted. Out of the other classifications we have, the four functional classifications, freeways are considered as uninterrupted. Okay, other examples can be rural two-lane highways and rural and suburban multi-lane highways. We will discuss them in detail later on. Okay, so on uninterrupted flow facilities, the characteristics of traffic stream are based upon the interaction between the vehicles and the roadway and the environment. Okay. How the traffic is moving depends upon the vehicles themselves, the design of the road, and the environment around the road, and that's it. Okay. Then we have interrupted flow facility, which is obviously the opposite of what I said earlier. So you have a fixed external interruption in these facilities. Interrupted flow facilities have fixed external interruption. So external, like you mentioned earlier, it has nothing to do with the traffic. It has nothing to do with the vehicle. Okay, it is something which you have put, independent of the traffic. Okay, so it is external, and it should be fixed. It should be fixed. So you may see on some roads an accident happens or some construction activity is going on. So the police may come and they may block the road. Okay, the contractor may block the road for his working. Is this an external interruption? It is external, right? It is external but not fixed. It's not part of the traffic, right? Okay, so if the blockage is there, somebody came and put the barrier or blocked the road because of accident or maintenance work. It is external, but it's not fixed. So that road, because of this interruption, will not become uninterrupted. Will not become interrupted. So let's say you had a freeway. Freeways are uninterrupted. That freeway has some construction work going on for 2 months. You would not say that the freeway became interrupted flow facility. Okay. So the interruption has to be external and the interruption has to be fixed. Then that road will become what? Interrupted. Now let's say there is a highway which does not have any intersections, but it has traffic jam every day for 2 hours. What is it? Interrupted or uninterrupted? Uninterrupted. Why? It's not external. Okay, and also it's not fixed. It's not fixed as well, right? After 2 hours, there is no traffic there. The traffic is moving normally. Okay, clear? If there is a traffic jam on a freeway, okay, which is otherwise uninterrupted. Because of that traffic jam, you will not call it interrupted, because traffic jam is part of traffic. Okay, so when traffic is higher, it's there, and traffic is lower, it's not there. So it's not external. What I say about external? It is independent of traffic. A stop sign does not go away when traffic is low. It's always there. So this traffic jam is not external, it's not fixed. It does not remain throughout the day. Okay. So what are the interruptions? We can have traffic signals, stop signs, yield is the American terminology. We call it the give way. Okay. So give way also means that you have to stop.
Like roundabout.
Roundabout, yeah. Roundabout is part of it. Any unsignalized intersection, so any intersection, because intersection you have access. So even if I don't put a sign there or a signal there or roundabout there, most of the times you will stop because of the access. Okay, so wherever I give access, it doesn't matter if I am giving a signal there or a sign there, it doesn't matter. I'm giving an access, so the driver, in order to keep themselves safe, they will stop. Okay, so like you see, even the access to parking areas are considered interruptions. Okay, as on. Traffic stream parameters means the data which you can observe for traffic, the data which you can collect for traffic. So there are two types of traffic parameters, two types of data which you can collect for traffic: microscopic and macroscopic. Okay, so what's the difference between the words macro and micro? You may say macro is a mall and it's a store, and micro is not a store, right? What's the difference between macro and micro? Yeah. So macro is something which is on a large scale, micro is something which is small scale. Okay. So what is the smallest unit of traffic? I just told you in the first slide. Traffic is made up of vehicles. Okay. So microscopic are those characteristics which belong to individual vehicles or pair of vehicles. So one or two vehicles. In microscopic characteristics, you are observing individual vehicle or a pair of vehicles. Okay, which you already did. Actually, you did both in the first part of the term project submission. So what were you measuring for each vehicle? Speed. The speed is what? A microscopic parameter which you are observing. The speed of each vehicle is a microscopic parameter. And macro is which belongs to the entire flow, a group of vehicles. Okay. Microscopic characteristics or parameters are those which belong to the entire group of vehicles. For example, you were there for 15 minutes, right? So you observed the speed and what? Numbers. Huh? So, for example, somebody observed 200 vehicles. And 200 belongs to what? One vehicle? No. Yes. The number which represents the entire group. Okay. So that number we call it flow of vehicles. So that number flow of vehicles is considered as macroscopic. Okay. So macroscopic is that data which is assigned to a group of vehicles, like the number of vehicles. Okay. And microscopic is that data which is observed or assigned to one or two vehicles. Okay. When I say two vehicles, I mean a pair going together. Not like one vehicle went now and the other vehicle went after 10 minutes. Not that pair. Pair means they are going together. We will discuss it, no problem. Okay. So you can see the list. Three parameters for microscopic, 3 parameters for macroscopic. We will discuss them in detail starting from now on. But I will not go in detail right now. But I just want to emphasize the difference between them. You can see in the list of macro and micro, there is one variable which is common, which is what? Is speed. What's the difference? I just told you speed is micro, right? And here it is written as macro as well. So I must be lying. Huh? Average speed. So for calculating average speed, you will take one value? No. Some of you can, I know. You are good enough. But normal people don't. Okay. So when you say average speed of vehicles, that means you are giving me data about a group of vehicles, right? Average speed of the vehicle was, let's say, 50 kilometers per hour. So that 50 belongs to the group of vehicles for which you took the average. So when you take speed as average, it becomes macro. But if you give me 10 different values, each value for one vehicle, that becomes micro. Okay. So we start with macroscopic parameters. Macroscopic parameter, the first one, again, you already observed is volume. Okay, and volume can be defined as number of vehicles passing a point, lane, or direction of the highway in a given unit of time. Okay, so number of vehicles per unit time, and that number of vehicles can be observed for one point, one lane, one direction, or for the entire highway. Okay, but it's basically a number per unit time, number of vehicles per unit time. Okay. So this is the basic parameter, the volume. But we said per unit time, right? Depending upon the unit of time, we can change the term. For how much time you observe the number of vehicles, or for how much time you are giving me the number of vehicles, the term will change. So volume is referred to when the number of vehicles are given per hour or per day. Okay, per hour or per day. Yeah. So you observe vehicles for 1 hour, you give me that number, I'll call it what? Volume. You observe vehicles for the whole day, 24 hours, you give me a number, and I will call it what? Volume. But what about the number which you gave me in the first submission? We call it what? I already told you, and it's written there as well. Flow. If the number of vehicles are observed for less than 1 hour, any number of minutes, less than 1 hour. Whether it's 5 minutes or 15 minutes or half an hour, any number of minutes less than 1 hour, we call it flow. So you give me a number for 15 minutes or 20 minutes or 30 minutes, I'll call it that you observed for your flow. Okay. Then we have flow rate. So flow rate comes from flow, right? Flow rate comes from flow. Flow rate, you take the value of flow and convert it to its equivalent hourly rate. Flow rate is flow converted to an equivalent hourly rate. How many vehicles you observed in 15 minutes? Please remember? 200. Sure? I'll check it. You don't remember. Okay. But let's say 200. Okay, let's say 200. Now, if vehicles come at the same rate, so in 15 minutes, 200. If they keep on coming with the same flow for 1 hour, I will have 800. So this 800 is now what? Flow rate. You don't call it flow rate. Okay. So flow rate is flow converted to an equivalent hourly rate. So volume can be vehicles per hour. Flow rate is also vehicles per hour. But what's the difference? Time, the time of observation. When you say volume is 800 vehicles per hour, that means you observe vehicles for 1 hour and then you got 800 back. When you tell me flow rate is 800 vehicles per hour, that means you observed for less than 1 hour and then you multiply with something to get into 1 hour. Clear? Okay. The volume is per hour, flow rate is converted to per hour. and flow rate is what are we converting to per hour for flow rate? The flow. Okay. There. For flow rate, you need flow.
Minutes is higher than 1 hour.
Then you don't call it flow rate, flow or flow rate. Flow is less than 1 hour, always. If it is 1 hour or more, we can call it volume. Okay, then we don't need the conversion, right? We already have the value for 1 hour. Okay, now keep these things in mind because we will repeat them again and again. These definitions will help you throughout the course. Okay, so we said volume is observed for how long? 1 hour more, right? Now 1 hour, that will be hourly volume. More than normally we then do it for the entire day, so daily volume. So we have hourly volume and we have daily volume. Okay, so we'll start with the discussion of daily volume. Where do we use daily volume? Daily volume is used for forecasting and planning. So if you are building a highway and you are trying to estimate what will be the volume after 20 years, so the engineer or the consultant will give you a value of daily volume. That per day volume on that highway is expected to be this much. Or you are looking at past trends. How much traffic has grown over the years in Bahrain, for example. So this growth rate will also be calculated for daily volume. Okay, we have methods for planning in which calculating daily volume is easier. Why it's easier? Because, for example, if I know how many students are there in the class or in the university, for example, I can estimate number of trips, right? A rough number for the entire day. But do all of you leave at the same time? No. Huh? For some of you, the morning starts at 10 a.m. and 11 a.m. and it can go up to 1 p.m. as well. It's still morning time and so on. So predicting daily volume is easier because if I just know the number, I can give you a rough figure. There are 2,000 students in the university. Maybe 40% or 20% of them are taking the bus. So the remaining 80%, I have the number of trips, right? But this is number of trips for the whole day. So daily volume, easier. But if I ask you, give me hourly volume, more complicated, right? We can do it. We do it. We calculate hourly as well. But you can now imagine it's more complicated. So that's why for traffic growth trends, for predicting things in the future, we use what? We use daily volumes, okay? For documentation and planning and so on. In daily volume, traffic is calculated as total for both directions. If I tell you daily volume on this highway is 50,000, this is 50,000 total of both coming and going for the entire day. Again, it's easier. Okay. Daily volume can be averaged in 4 different ways. There are 4 different types of average daily volumes. Okay, so we call them AADT, AAWT, ADT, and AWT. If you understand the term, you don't have to remember the definition. Okay, so focus on the term itself. We have AADT. AADT means average. We are taking an average, right? Annual. Annual means 1 year, right? And how many days we have in 1 year? 365, right? So it's an average of how many days? 365. Which values? Daily traffic. Which 365 values? Which were taken for the whole day. Okay. Average of 365 days of daily traffic. Average annual daily traffic. Clear? Huh? Okay. Next one is what? average annual weekday traffic. So what did we change? It's an average for the whole year annual, but only weekdays. Only weekdays. Which are the weekdays? The days we don't write. Huh? Sunday to Thursday for us, right? Huh? Okay, the days in which you have to see our faces. So we took out what? The weekends. Okay, because obviously in most of the cases, 90-95% cases, or the highways, this traffic is higher. So the worst case is this one, weekday traffic. Clear? Then we have ADT. So you are still considering the entire year for AWT. You are taking traffic from 1st January to 31st December, let's say. Okay. But within the days from 1st January to 31st December, you are only taking average of the weekdays. Okay. So whatever weekends were there, you did not observe them, you did not include them in average. Okay. Then we have ADT, average daily traffic. So it's an average for daily traffic, but less than 1 year. So no annual here. Annual is gone, right? So no annual. It can be 1 week, 1 month, 3 months, 6 months, anything less than 1 year. Okay. And then we have average weekday traffic. So now there is no annual, so less than 1 year, and not daily. There is maybe 1 week, but not 7 days of the week. Yes, the 5 days, the 5 weekdays of the week. Clear? Okay. So like I said, if you remember the term, it will help you. And yeah. Okay. Very simple, very small example, just to clarify the concept. Data is given for each month for a highway. Okay, so they have given us how many weekdays we have in the month, and you have to count them, right? You have to open the calendar, and you have to count how many weekdays were there in January and February and March and so on. You have to count them. Okay, they gave me total number of days in the month. Okay, you can open the calendar, you can count them. Okay, but there's a rule as well. Anybody knows the rule? How do I find out how many days are there in the month? Yes. You guys know that, right? Okay, but when I give the question, you guys forget. It happened. When I gave it for the first time, they were asking me how many days in a month. Obviously, I cannot tell how many days in a month. Okay, I said, okay, assume something. So people assume 30 days in February. Okay. Yeah, okay. Assume, but 30 days in February, really? Okay. So they have total number of days in a month. They have total monthly volume, total. So for all days. And then they have total weekday volume, which is only done for the week. Okay, so you can see column 5 values are less compared to column 4, and the difference is the weekends. Weekends are subtracted. Okay, and they are now asking me to calculate AADT, AAWT, ADT, and AWT. Okay, for each month. They start with AADT. Okay, so average annual daily traffic. So I need annual traffic. Okay, and then I need the total number of days as well. So in 1 year, I have how many days? 365, right? Not with February as 30, but normally 365 days, right? So we know the total number of days in the year. We just need total traffic in the year. So how much total traffic we have in the year? Summation of column 4. Okay, so give me a summation of column 4. Is given. Yeah, it's given. Okay, good. Okay, so AADT will be the summation of column 4 divided by total number of days in the year, which is 365, and you get how much? You mean 1,4, right?
Yes.
9. As vehicles per day.
We don't point, we go round up or down.
We do simple rounding off to the nearest number. So if it is 917.1, it's 917. If it is 917.8, 918. Simple rounding off to the nearest number. Okay. And believe me, if you got like 0 in this question, it's not because you rounded off wrong. Okay, so don't eat my brains after every question, Doctor, how do we round off? Okay, I don't care. Even if you put 917.9 as 917, okay, I don't care. Okay, your bosses will, when you graduate, when you go in the field, your bosses will fire you, and just let me know that. Okay, so now for AAWT, what should I do?
Number of vehicles in the year.
Number of vehicles in the year for the weekdays only. So summation of column 5, which is already given, 2.5 million something, divided by number of 260 is what number of weekdays. Okay, which is normally around 260. Okay, so how much is it? Again, vehicles per day. Okay, now for ADT and AWT. Okay, now you see you calculated ADT and AWT, right? Okay, and but then they are saying and ADT and AWT for each month. Can I calculate these two values which you calculated for each month? Can I calculate AADT and AAWT for each month? No, because it's annual. So AADT and AAWT cannot be for each month. Okay? Can I calculate ADT and AWT for the whole year? Okay? This cannot be this and this cannot be this. Clear? So ADT and AWT for each month. Just give me the values for January and you can calculate the rest of the values. So for January, ADT, total traffic in January, 208,000. No, sorry, 425,000. Total traffic in January. How many days in January? 31. So ADT for January will be 425,000 divided by 31. Okay, and that is how much?
13,701 and 9.
700.
709.
Okay, so this is ADT, took total traffic divided by total number of days. For AWT, you will take traffic of weekdays again for the whole January, which is 208,000 divided by the number of weekdays in January, which is 22. Okay, number of weekdays in January. So how much is that value? Huh? Okay, similarly you will do it for February and March and so on. Clear? Any questions? Okay. So I'll stop here and then tomorrow we will continue with the, yes.
I can observe that this half of the traffic is in the weekdays and half of the right?
Say again, say again.
I can observe that half of the traffic.
420, yeah, almost half, yeah.
So 2 days.
2 days are taking like almost 50% traffic. So it must be like maybe going towards a beach or something. Okay, so where normally people don't go in the week.
Traffic in the weekends.
Yeah, more traffic in the on the weekends. Yeah. Sorry. No, we all. Okay. Thank you.
This for all students or this one for our project?